Hello coders, welcome to my channel. I am Aniket and today we will discuss question from GFG, that is maximum number of people defeated. Let's read the problem. There are infinitely many people standing in a row indexed from 1. The strength of the person is at index I is I square. Given a strength P, determine the maximum number of people that can be defeated. A person with strength X can be defeated only if P is greater than or equal to X, after which the strength P decreases by X. So the first question arises is, what is the optimal way to tackle people? So the answer to this question is, we should tackle the minimum strength people first, so that we can defeat maximum number of people. So the optimal way to tackle people is in increasing order. So you have to first fight with one, then fight with two, then fight with three people, index at three people, then fight with that people which is standing at index 4, and so on. I hope you get this now. So, what is the optimal way? What is the brute force way to do this? So, the brute force way is simple. Brute force way is simple. We will go as the question states, and whenever our P is greater, is less than the strength of index I, so we should break out of the loop. Break out of the loop. The strength of I is nothing but I into I, as the question states that. So, what is the complexity for this approach? The complexity for this approach is O of n. Let's discuss the code of this brute force approach. It is acceptable, but before that, please hit the like and subscribe button so that you can't miss any POTT discussions in future. Let's discuss the code now. Here is my Java code, simple Java code, where I do the same. But is the firstly I initialize my start pointer to 1, which is denoting that we have to tackle firstly to the 1 people at index 1. So, and I will initialize my count to 0. This count will store the number of defeated people. I hope you got this. And while true, I will do this. So whenever our power is greater than the strength of that position of the people, so I will simply decrement my power to st into st, and I will increment my count. That is the number of people. Number of defeated people will increases by 1, and I will simply increment my position also. Then if P is less than the strength of that position, so I will break out of this loop and simply print the count, which is the number of defeated people, which is the maximum number of defeated people. I hope you understand my code and the intuition behind this, but this code takes O of n. Can I do it in better way? Something like O of log n? Yes, I can do it. We can solve this problem using binary search. So let's discuss the binary search approach to solve this problem. Binary search complexity is O of log n, which is the expected complexity by the problem also. First question arises that how can I think this approach? How can I think this approach? It is very easy because binary search will apply on which are those problems which are monotonic in nature. What is monotonic? Monotonic means something like true, 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 then false, 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 false. It means that at some index, till some index, the value is true, but after that, all of the values is false, and never this true become appear again. I hope you got this. What is the meaning of true? True means people is defeated. People is defeated. And false means people can't be defeated. So there is a monotonic nature in this problem because if we are unable to defeat uh, people at position I, then we are also unable to defeat people at position I plus x, where x is a positive integer. Similarly, vice versa is also true if we are able to defeat people at position I, then we are also able to defeat people at position I minus x, where x is a positive integer. So I hope you got this now why this problem is a monotonic in nature. So let's discuss the binary search approach. This is the standard problem where I do binary search on answers and find our answer in O of log n. Since we want to maximize our number of defeated peoples, so when we are able to defeat people at mid position, I hope you understand. I hope you know how to do binary search on answers. So when we are able to defeat people at mid, so to maximize our answer, we choose mid plus 1 to R as our next window. I hope you got this. Now let's discuss the code of this approach. But before that, please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. So let's discuss the code. Here's my simple Java code for this problem, where this is the range of our answer. L is equal to 0 and R is equal to 1e5. And firstly, I will initialize my answer to 0. Whenever our sum till mid is lesser than equal to p, so I will initialize my answer to mid, and my next window will be mid plus 1 to r. I hope you got this. And whenever it is not possible, so I will decrement my window, and my next window will be l to mid minus 1 to get the optimal answer. Some of you feels that why I take sum of mid to compare this with P, because let's say you want to defeat this mid people, so you have to at least power which is a sum of this term. sum till mid. This sum of mid will represent the sum of all strengths from this position, initial position to this position. I hope you got this. So if your power is not if your power is lesser than this sum of mid, so you can't defeat these number of peoples. So you can't defeat this number of peoples. But if your power is greater than or equal to this sum of mid, so you can't defeat these number of peoples, and it might be possible that you can find a better answer if you do binary search on this updated window. I hope you got this now. Why I take sum of mid, and sum of mid is nothing but sum of squares of all natural numbers till mid. There is a standard formula to calculate this, which is n into n plus 1 into 2n plus 1 divided by 6. It will give you the sum of first n natural numbers squares. I hope you got this now. Why I take sum of mid lesser than equal to p as our first condition. Similarly, you will find at last your answer and simply typecast into your int and return it to the function. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. Thank you for watching my video.